Good afternoon to one and all. Keep your face always towards the sunshine, and shadows will fall behind you. Once again, I welcome you all. It's given me an immense pleasure to welcome you all. I welcome our HOD ma'am, Department of IT, Dr. N. Kanya ma'am, and guest day of the speaker, Ms. U. Surya ma'am, Assistant Professor in the Department of IT. On behalf of the Department of IT, once again welcome you all and for taking your time and keen part in this event. And I'm sure that you all will feel enriched with the knowledgeable. And after the completion of this event, I welcome you once again. And now I would like to call upon Dr. N. Kanya ma'am to deliver a welcome speech.
Thank you, Charamati. Good afternoon, students. Happy to see you all after a break after semester. Right? This is the first event of our semester for this even for our department for this even semester. That do guest lecture on network simulation, right, by our faculty member. I like to thank first, I'd like to thank the Almighty for the successful beginning of this semester and events, and I like to thank our founder chancellor, Dr. A.C. Shanmugam sir, and President Engineer Arun Kumar sir for their support to conduct various events and to achieve various heights. I'd like to welcome today's speaker, Miss Surya. She's so special to us as she's not only our faculty and also our alumni in her UG and as also in PG. She's studious in UG as well as PG and much active in her during her college days. I'm happy to welcome our alumni as our resource for the event. Welcome, Surya, for the session. Hope everyone will enjoy the session today because network simulation is an interesting and need of the very needed subject for second year as well as the third year, right? Hope everyone will enjoy this one, and I like to welcome all the student participants, to students who's taking part in this event guest lecture. I wish you all the best. Kindly be active throughout the session and post all your queries in this chat box. Once again, welcome you all. And also, I like to take this opportunity to thank the coordinator of the event, Dr. Dalia Sam. Her tireless work made this event grand success. Thank you, Dalia ma'am. Once again, on behalf of the Department of Information Technology, I'd like to welcome you all for this guest lecture on network simulation. Thank you.
Thank you. Thank you, ma'am. Next, I would like to call upon Kirtana from third year to give an introduction about the guest speaker of the day.
Kirtana, your video is not visible, voice is not heard. Kirtana? Okay, Charumati, you can continue. You
Yeah,
can
ma'am.
introduce. Okay.
A very good morning to one and all present here, and let's begin this wonderful session with a positive quotes. The purpose of the education is to replace an empty mind with an open one. I would like to welcome today's guest speaker, Ms. U. Surya Ma'am, Department of IT. I am very much happy to acknowledge that Ms. U. Surya Ma'am is an esteemed alumni of Dr. MGR Educational and Research Institute. She has completed her BTech in the year of 2017 at Dr. MGR University, and she was awarded a silver medal for obtaining second rank in the overall university. She has also completed her MTech in the year of 2019 at Dr. MGR Educational and Research Institute, and currently she is working as an assistant professor in the Department of IT at Dr. MGR Educational and Research Institute. And she has a wide knowledge in the following domain: big data and data analytics, and digital marketing, computer networks. I once again welcome our esteemed guest, Ms. U. Surya ma'am. Welcome you, ma'am.
Thank you, Charumati, and thank you, Kanya ma'am, for giving a wonderful welcome. So, so let's get started with our session today. So we are going to discuss about computer network simulations and modeling. So let me present my screen. So today our topic is about networks modeling and simulation. So as you all know what is meant by computer network, and we are going in more deep about modeling and simulations of both the networks. Okay, so let me start with the content. So what we are going to cover in this today's lecture. So we are going to discuss about introduction, network simulation, and TCP and UDP inside your network simulation. Okay. So under the introduction, we are going to talk about what is mean by network and what is mean by network modeling and simulation. It's a general one. And in the second category, we are going to discuss about network simulation. In that, we'll be covering NS2. So actually, it is a one tool where we are going to discuss about this tool today, NS2, and the initialization, nodes, links, and queues. And the third one, we are going to discuss about TCP. What is TCP and FTP, which is worked in network simulation. And the fourth category is about your UDP and UDP and CPI. Okay, let's get started with the first one, network. So network is a complex mix of application, communication protocols, and link technologies, traffic flows, and routing algorithm. Which means, as you all know, network is not a simplest one. Yes, so it is a huge actually. Actually, it is a very complicated one where every protocols needs to be connected, and we need to connect with the different kind of technologies, and there must be a traffic flows, and lot of algorithms are available to run a network, right? So it is really a which is a very complex one, and if you want to design or process or anything with your network, what you have to do, it is really a challenging task actually. Based upon your cost and capacities, we can say. Maybe the cost may be highest, and capacities, the space, and everything. So when comparing to all, your network is very challenging task to run. Yes. So to overcome the difficulties and the even a problem, the complexities, we need a network modeling and simulation. So to overcome all your network issues and everything, to overcome the complex problems, they will be using networks modeling and simulation. Okay. So there are wide range of network modeling and simulation tools were used today. Actually, today we are using many tools actually based upon the companies or based upon the centers. They are using different kinds of tools for the modeling and simulation, and these tools can be divided into four categories. Okay, not only the simulation tools, we have a n number of different tools. So this will be categorized into these four categories. One is analytics, second one is simulation, third one is network topology discovery, and the fourth one is protection tools. Okay, different four classes of tools. So today we are going to discuss about the simulation. Okay, actually, as your topics knows that we are going to discuss about only the simulation. So simulation tool. So here, see, as I said, we have four different categories of tools. In that, we are just going to discuss only about the simulation tool. Here, the simulation tools is also categorized into the field of educational tool, commercial tools, and specialized tools. So you have three different criteria where I have given the example for you where we can use the simulation actually. So then go with the list of network simulators. So these are some few of network simulators where your NS2 or NS3 is an open source and it is freely available. And OpNet and NetSim, GlomoSim are some commercial and open source codes are editable too. So, let me tell you what are a few network simulators, list of few network simulators, because there are n number of simulators are available. But here I am going to list you very few things. The first one is NS2 and the next one NS3. So don't get confused what is mean by NS2, NS3. NS2 is nothing but network simulator version 2 and NS3 is nothing but network simulator version 3. And we'll be having a tool of OpNet, and the next tool is OmNet plus plus. So I'm giving very few examples, NetSim and Real, and at last I'm giving Qualnet. So these are the some list of few list of your network simulator. Actually, we have more simulator tools also. Okay, so today we are going to discuss only about network simulation version 2. So it is a technique where a program models the behavior of the network. Actually, it's going to cover the behavior, how your network is actually, what it means. So that is what the network simulation. So simulation is a meaningful evaluation approach only when it produces a trustable result. Trustable is nothing but we can say the exact result, the correct result. Okay, the original result. So it's a meaningful evaluation for trustable. So obviously, when we are going with simulation, you may get a trustable result or the correct result. And environment of network simulator. So network simulation is mainly based upon two languages. As in many other subjects or anything in computer, if it comes to computer, what we'll be learning? We'll be learning about the languages, programming languages, right? So same way here in network simulator also, it is based upon the two different languages. So one is C++ and another one is Odcl. So C++ it's nothing but it implements the code that executed frequently. So as you all know what is mean by C++, let me explain you Odcl. So Odcl is nothing but object-oriented version of tool command language. So it is nothing but the combination of object-oriented concept, okay, OO concept, and with the tool command language. There is a language of Tcl, tool command language. So the combination of both object-oriented and tool command is together is called as a OTCL. So this is what I thought to explain you. This is TCL plus OO. So TCL is nothing but tool command language and OO is nothing but your object-oriented concept. So both together you will have a program as OTCL. So now come to the structure of OTCL. So this is how your structure will be. So OTCL script simulation program. So this is what the script where I'm going to write my own script. So with the extension of .otcl. So here my extension will be .tcl. Sorry, my extension will be .tcl. So this is where my program is started, where I'm writing my script and with the extension. So as I said, with the extension. So after the result space, what you will get, you will be getting a simulation results. So as the result page. So from this result, where you can analyze your data, you can analyze or you can find get the data, or else what the one more method is result. You want to view your result as an animated view. Suppose like a graphic, not graphical representation. If you want your screen to be in an animated format, so then we can go with the NAM. NAM is nothing but network animator, where your result will be in an animated format. Okay, so as now we are started with the program, we are going with the simulation result. You can also analyze your result, and if you want, you can view your result as an animator page. It is your that is called as a network animator. So next, let me tell you in detail about it. So as I said, right, TCL simulation script. So what extension we are going to say? It is with .tcl simulation script. where after going this, it will be working on with two different programs. As I said, you the NS will be worked on two things. One is C++ and another one is Odcl. So Odcl is nothing but object oriented plus tool command language, where both combination. So NS is nothing but your network simulator. This will be run with the NS command. So whenever we are writing a program, will be running with the NS command. So this is how your script will be processed, and after this you will be getting a simulation trace file. Yes, simulation trace file. So the result page, okay, you can tell it as a result page. It is simulation trace file that can be viewed either by the animation method or by the graph. So we have two different things where we can view your trace file. So two methods are available. One is with the animation nam, as I said you nam, and another one is plotting, which is mean by graph view. So let me tell you. See, this is what the NAM. So NAM will show you the directions where the next node to be connected and where is the next process is going to be held. Everything will be shown over here through the animation method. So the next one is, or else you can view a result as a graphical representation like this. So you can also view your result in a graphical representation. This is what after the TCL process, your results will be viewed in these two categories. Yes. So next, we have to know the programming TCL, basics of TCL programming. So what is mean by TCL programming? So here I am talking only about network simulator version 2. That's what I have mentioned here with respect to network simulator 2. So everything is going. We are discussing about the network simulation 2. Okay. So before we get into the program, we need to consider the following things. So before we are going inside the program, what are the important things are needed for programming, for TCL programming? Okay. So first step is initialization and termination aspects of the network simulator. First of all, you have to initiate your program, and once the initialization is started, what we have to do at some set of time, we need to terminate your program. So these two things are very important for a network simulator. Then next category we will be discussing about what is meant by network nodes, links, queues, and topologies as well. And the next one is defining the agents and their application. And next, network animator, as we displayed before, it's a NAM, that is a animated view. We'll be discussing in detail about it, and at last we'll discuss about tracing. Okay, these are the basics of TCL program. I'm just giving the headings, so we'll discuss one by one what it is. So first step, as I said, your first step is initialization and termination aspects. So we'll move on to the initialization. So first of all, I'm going to initialize my simulator. Yes, network simulation. For that, I'm giving the command is set ns new simulator. This is what my command. Here ns is nothing but network simulator. There's a keyword where I'm giving set ns new simulator. So here ns is your variable and new is your keyword and set is a command. Okay. So ns is a variable being initialized by the set of command. So here this ns is initialized by this command, which means the set command, and this new simulator is initialized by ns. So this is what the initialization state. And let me give you example like my first TCL program. So when we are creating a simulator, so the first step, suppose I want to create a simulator, what is my first step is set ns new simulator. Here what happened? Your program, your simulator will be get started. So this is what my first step, set ns new simulator. And these two things are like a name trace file or a trace file and NAM file. NAM trace file, it's nothing but where your things going to be saved. Yes, saved, or you're going to be write. Yes. So set my trace open out.tr. So this tr is nothing but your extension. Out is the name of the file, and w is nothing but writable format. So whenever we are giving a command, we need to give it in a writable format. Why? Because suppose if you want to do some alteration, or if you want to do something with your program or command, uh, you need to access it. Yes, suppose if I'm giving in a readable format, so what it will happen? So only you can view it and just you can read out the content. That's all. But if I'm giving W, which is in a writable format, where wherever we can write your commands, or if any changes you can write it and you can activate it. So both is for same thing. It's like set my trace open out.tr, here out.nam. So here nam is nothing but it's the extension of your trace file. Okay, nam is nothing but the extension. Here same way, here out.tr is nothing but tr is your extension, but out is your file name. This out is your file name. So I'm going to start the program here, trace file, where I'm going to give all my data and everything over here. Yes. So NS is nothing but network simulator trace all dollar my trace. So where it will call out this set of function. So this will be called out over from this command. Okay. So we have a simulator. The first step, we are just going to create a simulator, that is set ns new simulator. Whenever the program starts, this is what your first statement. And the second one is creating a trace file, and third one is creating a nam trace file. Okay. Suppose I want to finish. So as I said you, we have discussed, right, initialization and termination process. So suppose I want to finish my procedure. So this is where my commands or anything is going to be ended. What I'm going to do. So this is what the program for you. This is nothing but procedure finish. So procedure finish for that global ns my trace my name. So you're calling out why we are keeping it global, in the sense we can access it. Anyone can access it. It is in the open, and ns flush trace, and I'm going to give the close command where my trace file and my nam file will be closed. For that, I'm calling out this function. This is called as a procedure finish, where I'm going to close my trace function, as well as I'm going to close my nam function. Okay. So again, I'm going to execute that nam out.nam and exit. So exit in the sense it will come out from your program. In total, it will come out from all these things. So first step, what we have done with the creating a simulation, and we are creating a trace files and nam files. After that, we have just discussed about the procedure for finishing your statement. So finishing is simple as I'm giving close command to finish both categories. Yes. So the next one, suppose start and end. So my simulation, when it gets started and when it is getting ended. So at the start of the simulation, what you have to do is $ns run. So what it will happen, your simulation will be started, your process gets started at this stage. Suppose I want to end the program, so $ns at 125.0 finish. So what happened, my program finished within this seconds. So within the 125 seconds, my program gets finished. So that's what the command is. So $ns run and $ns at 125 finish. So when it started, from the starting time till 125 seconds, it runs, the program runs. After that, it's get be finished. So next step. So we have completed the first one, initialization and termination process. So the next step is nothing but your network nodes, links, and queues. Yes. So here, see, we have a nodes in the sense it will be continue. Your packets and data will be continue by node, one node by another node, right? So see, your packet will be dispatched over here, and it will wait for the output queue. So your queue will be started. See, it's moving on to the next node. So the same process will be continued for the next step. Again, if you want to move on to the next node, again the same procedure and same process will be continued. So here you have a packet crossing link. So there is a links which is crossing your packet from one packet to another packet. Using the link, it will be crossed, and partially received packet. So this packet is partially received for me. Still, the to be coming. Still the packet needs to come. So it is continuing process. Again, it's coming. So not yet completed. So that they have mentioned here as partially received packet and partially sent packet in the sense. So particular partial packets only sent. So need to be sent more packets also. And packet waiting in the queue. So if you see here, the packet is waiting. Okay, when this all packet link is crossing, when all send it to the node, till that your next packet will be waited in the queue. So as like we are all standing in a queue or line somewhere, even you just think like a ticket counter where you're all waiting for a ticket. Don't say that now we are all in online, so we are taking tickets from online. Just imagine that suppose if you are standing in a queue, so what it will happen? So each and every step. So one member have to move first so that the next member can come. So same way here also the packet is crossing. So they have mentioned you. So this is at the stage of ticket counter. Just think this as a ticket counter where I'm the data is processing. So partially I have submitted or I paid money or something. So the partial process is done. Still I need to finish my full process. So that's what here also they have mentioned. Partially the packet is received by the another node. Here the partially the packet is sent by the this node, current node. Yes. So this is what the process it will happen. Again the same, the buffer will be saved and it will dispatch your packet through your output queue. Again it will move on to the next node. So same, the next process will be continued again. So this is what the nodes, links and queue. So for that, let me tell you with the example like set n1. So node 1, that is n1, new node here. Again, I'm setting n2, that is node 2, where new node. So for this, what I'm doing is $ns. NS is nothing but network simulator. So duplex link is nothing but I'm going to connect these two nodes. So there are, as I said in the diagram, we have two different nodes. That must be a connection, right? For this, I'm using the command duplex link where I'm going to connect my N1 as well as N2. So $N1 and $N2, where at the speed of 10 Mbps. So it will be run with the 10 Mbps speed. And here you have one more thing is drop tail. What is mean by drop tail is nothing but so once the packet is arrived, okay, the limitation, suppose I want to send 25 packets, so but the receiver side the limitation is 20. So what happened, the other packets need to move for the some place. For that I'm using drop tail. So if you use this option, what happened, the excess packets, so suppose more 5 packets, like as I said 25 packets I want to send, but only 20 is the limitation. So what it will happen, the 5 excess packet will be dropped into your drop tail. So this is what the concept here. So same, even the content is same, but if the buffer capacity of output queue is exceeded, suppose my queue is around 20, but I have exceeded my limit and I'm sending more than 20 packets or anything. So what it will happen, this will be dropped into your drop tail option. So for that only we will be using your drop tail option. So see, I have given you an example for this. So set queue size of the link. So I'm giving the limitation that NS queue limit is N1 and N2 and I'm giving the limit as 20. So my limit is I'm giving 20. Suppose I'm receiving more than 20 packets. So at that time, your data will be dropped into drop tail. So you can also give 30 or 40. It depends on you. Just for example, I have given 20. So till 20 packets, it will be accepted. So after that, after the queue limit is only up to 20. So 20 will be accepted. After that, that will be into a drop list. So and the next one is agents. So agents, we are going to discuss about TCP and UDP. Here I'll tell you what is mean by FTP, CBR, everything. Now we'll start seeing what it is. First of all, let me tell you, TCP is nothing but connection oriented service. Yes, TCP is nothing but connection oriented service, and UDP is nothing but connectionless service. So connectionless service. So TCP is nothing but transmission control protocol is nothing but your connection oriented, and UDP is nothing but your connectionless service. So let's see one by one. So first, TCP, transmission control protocol. So it is a important network protocol that lets two hosts connect and exchange the data streams. Where two hosts are there, if they want to connect and exchange their data, you can use your transmission control protocol. So TCP guarantees the delivery of data and packet in the same order as they were sent. So if you are going with TCP, whatever order you are sending the data, suppose I'm sending 1, 2, 3, 4, 5, so the data will be sent in the same order. It will not be mixed. It will not send the first, it will be sending the fifth packet and fourth packet. After that, it will coming on to the first packet. Not like that. It will send in an order. So the same order as they sent. Suppose I'm sending in 1, 2, 3 category, then it will be sent into 1, 2, 3 category. Suppose I'm sending it as a 3, 2, 1. So as it is same order, what you are doing, the same thing it will be sent. And TCP requires bi-directional links. Why we need a bi-directional links? Because to acknowledge your returns. Suppose I'm giving something, I'm giving like as a sender, I'm sending some request. So I need a answer, respond that acknowledgement that this is what my concept is. So I want my acknowledgement. So that we need a bi-directional link. So if you are using bi-directional link alone, you can get your acknowledgement. It is written to the source. Yes, for TCP. So as I said, right, you can, I think you can able to see this diagram. So suppose I am a sender, I am sending something. So from receiver side, I need a acknowledgement. Acknowledgement in the sense that receiver is telling that I received the data. Yes. So same way again, I want to acknowledge that the acknowledgement is received like that. So that will be a acknowledgement. For that acknowledgement only, we need a bi-directional link. Not only a single way communication, it must be a bi-directional. Yes. So now we are going to discuss with setting a TCP connection. How we are going to connect the TCP connection. So set TCP new agent that I'm calling out the TCP, and NS attach agent $n1. So n1 is nothing but your node 1 where we called in the before previous slides, right? So that is your node 1 is nothing but your TCP. I'm calling that. Yes. So this is like a sender side. This two line is for a sender side where I'm setting the new agent and I'm attaching this agent. For the receiver side, again, for sender side, you have entered two lines of coding. What we are going to do for the receiver side, this is what your command is, set sync. Sync in the sense you are getting a response. Okay, receiver side, set sync, new agent or TCP sync. Okay, again, NS attach agent to N2. What is mean by N2? N2 is nothing but your node 2. So that will be written to you. That is the receiver side. So the next one is NS connect TCP and sync. Now I am going to connect my TCP and sync. TCP is nothing but the sender side and the receiver side. I am going to connect these two connections. Okay. So the next one is TCP set FID1. What does it mean by FID? So it's nothing but the flow ID, because TCP alone have a n number of connections, not only a single connection. It's not going to end up with a single connection. We have a n number of connections. Yes. So for that I'm mentioning which connection it is. So FID is flow ID 1. So this is what my first connection. So I'm giving that flow ID is 1. So I'm setting that this is what my first connection. And TCP set packet size I'm giving 552. So if suppose you may ask what does mean by packet size 552 in the sense till this packet size you can send or receive the data. Yes, the sender can receive the data around 552 packets. Okay. Suppose you can also reject this point. It's not mandatory you need to write this set of line, this last line alone. It is not mandatory that you need to write this line alone. Line. Why? Because if suppose if you're not writing this line, if you're not mentioning the packet size, what it will happen? Automatically, your packet size is will be taken as 1,000. Okay, the limit is 1,000 actually. So if I want to give some restriction or I want to give something, this is what my packet size I want to give in any situation. I want to restrict so that at that time you can use this command line and then you can restrict that only 552 packets will be allowed, or else you can just ignore this line. So automatically your program will consider that this will be reaches till 1,000 packets. So normal actually the normal packet size is 1,000. Okay, the limit is 1,000. That will not go beyond 1,000. So the limit is 1,000. It depends on you. If you want, you can use this line and you can give a number of packets, whatever it is, whatever according to your coding and your part of view. How many packets you required, you can access it, or else we can ignore this line. So the next one is so we have seen TCP, right? In TCP, I have mentioned that FTP, file transfer protocol. So that we are going to discuss now. What does mean by file transfer protocol? So the name itself tells you it's just transferring a file from one host to another. So from one place to another, the files will be transferring. That's it. So FTP uses the services of TCP. Actually, this FTP protocol will use the service of TCP. Through TCP, the FTP will be worked, and it needs two connection actually. So what are those two connection? The first one is port 21. Port 21 is nothing but it's used to control connection. So it may be a different connection. So to controlling those connections, we need a port 21. And one more is port 20. It is nothing but is used for data transfer, where you want to transfer your data from one place to another. We need a port 20. So these are the two connections, where port 21 is used for control connection and port 20 is used for data transfer, right? So now we'll see again the program. So initializing FTP over TCP. Here you no need to give a new you no need to give a command like this. So here we have called the new agent and calling up the new agent like TCP, right? But in FTP, you no need to call the agent. Why? Because we are calling FTP over TCP. So over TCP only we are calling your FTP, so that you no need to mention any new agent or new set of things and all. Just simply we can set FTP new applications FTP. That's more than enough. And here the next line I'm attaching that FTP attach agent TCP. In the sense I'm attaching from TCP I'm attaching this FTP. That's all. This is what my command I'm giving here. As like if TCP, you no need to mention that new agent FTP and all. You no need to mention the new command, new agent. You're just you're just attaching that old agent. Actually, agent TCP. We are attaching TCP agent. Okay. This is what your FTP, file transfer protocol. So the next we'll move on to the UDP. So user datagram protocol. So the user datagram protocol or UDP is a communication protocol used across the internet for especially time sensitive transmission such as video playback or DNS loop. Time sensitive. So it is mainly actually why we are using user datagram in the sense it is mainly covered this point actually, time sensitive transmission. So it speeds up communication by not formally establishing a connection before data is transferred. So there is no changes in command. Same way, set UDP, new agent UDP. Again, what I'm doing, I'm calling out the N1. N1 is nothing but so the node 1, the first node in under the UDP. And here for receiver side, I'm using null. So where in TCP we have used a sync, right? So here I'm using null, set null, new agent null. So here what happened again, N2 is nothing but your node 2. And I'm going to connect your UDP connection as well as your null, UDP and null. Right? So next, see in this line, I have mentioned that UDP set FID2. FID means flow ID. That flow ID is in a 2. So in TCP I have mentioned 1, and here I have mentioned 2, because the as I said you have a n number of data will be flowed in the TCP or UDP wherever it is. So you have to call out actually where the data is. So for that I'm using this line, and can you see I left one more line over here? See, is it correct? So TCP, we have given the size of the packet. We have give the limitation of the packet in TCP. But here I have left that point. Why? Because so here automatically it will consider that 1,000 packets will be allowed. That's all. And automatically it will consider the limitation is 1,000 packets. So if I'm not considering anything, if I'm not mentioning the packet size, the limitation of the packet size, so automatically the data will be thinking that the limitation is 1,000. So that's why I have not mentioned here, so that you can understand, right? So see here we have mentioned TCP set packet size is 552, but there I have not mentioned anything. So automatically the packet size will be considered as a 1,000. Clear. So we'll move on to the next CBR. So it is a CBR is a connection with your UDP. So CBR is nothing but constant bit rate. So your bit rate will be a constant. The same. Okay. Constant bit rate is a term used in telecommunications relating to the quality of service. So when once it is a constant bit rate, automatically it will be talking. We'll be talking about the quality of the service. So compared with the variable bit rate. So here, see again, I'm setting the CBR over UDP again. So set CBR, new application traffic CBR. You don't need to call the new agent, and you're just connecting this, attaching this with your UDP now. See, CBR set packet size is 1,000. So here I'm mentioning that my packet size is 1,000 and rate is 0.01 Mbps speed, and CBR set random false. So I'm mentioning one more point, that is here I'm giving the packet size is 1,000. So we can't move around over this. We can give only the 1,000 because it's a limitation, and I'm giving the rate also. Yes, the bit rate as 0.01 MB. So the next one, scheduling event. Suppose if I want to schedule an event, see my NS starts at zero point 0.1 second. Okay, this is starts at 0.1. Your CPR starts, and FTP starts at zero point 0.5, and the ending time again it will show you 100.1 second. Your CBR is stopped in this. It's ended, and again same way your FTP also ended in the 100.5. So NS run. Run is nothing but you're just going to run out the program. So the next one. So we have completed one more category, nodes, links, and TCP UDP. The next one is network animated NAM, which we are going to discuss now. Visualize the network in the NAM. So visualizing. So this is how your NAM will be looks like. So it will be showing where the packets are moving, transferring, everything will be shown over here, and position is random or constant. Okay, and see I'm giving that ns duplex link op n0 and n2 orient right down, and duplex link op n1 n2 orient right up. So this is what node 0, this is node 1 and node 2, and this is what node 3. So how the connections, okay, that's what they have given in this set of lines. So ns duplex link op n0 and n2. See, there is a connection between n0 and n2 over right down. So it's moving on the right hand side, right? It's moving on the right hand side. So that's what they have mentioned as n0 and n2. See in the next line, n1 and n2. See, n1 and n2. Again, right up. So it is from right to down, and this is from right to up. So n1 to n2. And n is simplex link n2 n3, that is orient right. So see it is not up or down, so it is in a straight line, so that I'm mentioning only orient right. So from this side to right. Next, n is simplex n3 ns2. So n3 from here to this, again orient left. Okay, from this side to this. It may be a bidirectional. So opposite side also we have to mention. So like this, we have a n number of commands. So I have given for you one example for it. I mentioned this set of points. For this, if you want to create again all these things, you can go with more connections. You can go with N2 connectivity between N2 to 4. You have the connectivity between 3 to 4, and go with the connectivity between 3 to 5. Yes. So simply I have shown you only for the first three lines. I have explained this diagram. Okay, don't consider for the overall. I'm just taking off only for the first three lines. I'm showing this connection. So after that, you can do the same procedure. Okay, so that you can get the animator like this. And see, so the color N is color 1 is red, and N is color 2 is green, and labeling. So I'm going to label that N0 label UDP0. So N1 label UDP1. So N2 is my destination. So which means the 0 is in a UDP0 state, and N1 is in a UDP1. N2 will be in a destination. So it means we are starting from the source. So we are anyhow we need to reach the destination. My N2 is my destination. That's what I have mentioned here. So the next last and I think that is the last topic where you are tracing. So NS simulation can provide visualization trace as well as ASCII file format. So American Standard Code for Information is that will be corresponding to the events that are registered at the network. So you will be considering here NS simulation tool will produce both the visualization trace as well as your ASCII format. Okay. So if you go with the tracing objects, we have a four tracing object, ENQT and NQT, DQ, DQT and receive T and drop T. So here NQT is nothing but arriving the packet. Where my packet is arriving, that is called as your NQT, and DQT is nothing but it will hold your information. Yes, it will hold your information like dequeued. It's not in a queue. Okay, it is not in a queue. It will hold your information. We can say like this. It's not in a queue. It will be hold your information. That is dequeued and receive. So as I'm receiving the packet, so that is called as a receiver side. Receive T and drop. So I explained you drop, right? So it's the same thing. I'm dropping the packet. Yes. So suppose the packet is overflow. As I said you, if I'm giving the restriction is 20, but I'm sending the more than 20 packets. So what happened at the time? The packet will be dropped. So this is what the four different objects in your tracing. See, and if you want to understand the trace clearly, you need to know about this structure. You have a 12 set of things. The first one is event. Second one is we need to consider about the time from node to node. So from which node it is starting to end of the node, which it is ending. And packet type, whether it may be TCP or UDP or FTP or CBR. So I'm giving the packet type and the packet size. So if you want to give the limitation, you can give the packet size, or else if you don't want to give anything, you just let it be. So it automatically accept that the packet limitation is 1000, right? So the next one is flags and FID. FID is very, very important whenever we are giving, because n number of flows will be there. N number of flow controls flows will be there in your TCP or UDP. So flow ID is very, very important, where actually the things to be stored. Yes. And the source address. Source address is nothing but, suppose I'm starting from my system, then my system address is nothing but the source address. Destination is where I'm reaching. That is what my destination, right? Destination address. And sequence number. Yes. And the packet ID. So these are the 12 things which we need in a trace file. So suppose if you comes with the event, it may be a NQ or DQ, or you can receive the packet or dropped, as we discussed here, NQ, DQ, receive or drop. So this is what here the event is. whether it is an NQ or whether it is a DQ or whether it is like a receiver, received, or whether it is the drop. Okay, the next one is time. So time in consumption. So next one is from as I said, I think I explained all this. So from node is nothing but from where the link is started. Okay, recorded this trace event. So from back till the end. So from node to till the to node. Okay, and the packet type is whatever it is, the size flag, the FID, source address, destination address. So these all are very important to understand the trace. So main this one EQ, DQ, NQ, and DQ. See, I have given you the example. The first field that is nothing but we can identify with the plus, minus, R, and D. So NQ, DQ, and receive and drop. Okay, and the second field is time at which the event occurs. So, at what time the event is occurring. The third field is the input node of the link at which the event occurs. That is your input node, and the fourth field is your output node. As I said you here, from node to end node, that is to node. So, from node is nothing but your input node, and to node is nothing but your output node. The fifth field is the information about the packet type. So whether it is a UDP or FTP. The sixth field is packet size. So as I mentioned here, packet size. The seventh field is information about some flags. So we are giving some informations. And the eighth field, flow ID for IPv6 that a user can set for each flow in a Tcl script. As I said, so suppose I'm giving FID1, so the flow will be in a 1, ID1. So it is ID2, the flow will be in a ID2. So you have to mention, you have to give the ID for that. Yes. So the ninth field source address, the 10th field destination, and the 11th field is network layer protocols packet sequence number. So whenever we are sending a packets, we need some sequence number. Sequence number is nothing but this packet has to be in the first. So sequence. So I'm sending in order, right? So this has to be reached first. So the sequence number will be 1 for that. So the first one has to be reached. So that's what I'm mentioning it as a sequence number. Okay, I'm giving a sequence number for my packets, and the last field is unique ID of packet. So there will be a unique ID for each and every packet of data. So your data is segregated and it is sending as a packet. So each packet have a unique ID. That to identify, right? We need to identify this is what the different packet and this is what the different packet. For that, what you will be doing, you need to identify with only the ID, not packet ID. As you all have your ID cards, right? Having different ID for you, different registration number. So same way, your packet also has some unique ID. So this is what they have mentioned as unique ID of packet. Yes, I hope you all clear with this points because it's very important that the structure of trace file. Because without understanding the structure, we can't go with what is meant by tracing, right? So, in this simulation tool can produce visualization trace. So, visualization, as I said. That's all. I hope you can understand. If you have any queries or any doubts, you can ask. Yes. So if you have any queries or any doubts regarding your simulations, you can ask me now. Okay. Dalia ma'am. Okay. So as I said, the network simulation, as I said you, only we need to know about what is meant by the simulations and how it is starting and how your statements are getting ended. So in between, what are the process? That's what yeah, simulation actually what we are discussing is so far. So we have a classification and we have a different tools and everything, right? So let me So let me tell you with this. So we'll wind up again with this. So let me I'll go with and give a little refreshment of all this. So we have discussed what is mean by network, and we also discussed what is mean by network modeling and simulation. So why? So actually, network is a very complicated one. So to solve those complexities, we need a network modeling and simulation. And the second category in simulation itself, we have a initialization, node, links, queues, and everything. Yes, we have discussed how to initialize a program and how the node and link and queues will be connected. And we have also discussed about what is mean by TCP, Transmission Control Protocol. It is for connection oriented actually, and UDP is nothing but connectionless. So we have two different things. TCP is for connection oriented, and UDP is for your connectionless. And we have discussed about all this thing. If you have any queries regarding this, you can ask me, or else and yes, any queries you can post it in chat box. I'm ready to give you an answer. No, no queries. Okay.
Okay, I think students have understood very well. That's why no queries. Okay, just we'll wait for one more
Yes.
minute. Okay, students, feedback and attendance link will be posted in the chat box after some time. Okay, there is one. Can you see there is a question?
Yeah. This are all subject common hacking like as tracing. So when you're going with hacking, that is a different one. Like it may be a connectivity with your networks. Always you have a connection. But here I'm just telling what is mean by tracing and everything. It's just like a definition I have given you, like what is mean by tracing and how the files are. But obviously, if you're going with hacking, in the sense, all will comes under your tracing also will comes under your hacking. So all for all subject come in hacking. Subject in the sense, no, it's not like a subject. It may be a part. Okay, it's not like a subject. Okay, tracing. I think you can you understand in a different way. It is not a subject. Yeah, any other queries? Okay, I think no queries from your side. So thank you all for attending the session. Thank you. Thank you so much, everyone, those who are posting the shows and posting the event and everything. Thank you all. Thank you, dear students and everyone. Thank you. from your side. Thank you all.
Good afternoon. Good afternoon, all. Myself, Tharni from third year IT. It's a great honor and privilege for me to propose the vote of thanks on this occasion. Let me first start with thanking the Almighty God for making this series a resounding success. Then I thank guest lecturer Mrs. Surya ma'am for the great session. Thank you, ma'am, for such a knowledgeable and enlightening session, which had surely brought amazing transformation in students. It's my pleasure to thank our honorable and dynamic president, ACS Saran Kumar sir, who has been a great continuous support system and always encourages us to take a step forward and start ahead. I also thank our Vice Chancellor, Dr. S. Geeta Lakshmi ma'am, Registrar Dr. C.B. Palnivel sir, Additional Register Dr. V. Cyril Raj sir, and Dean Engineering and Technology, Dr. Etiraj sir, for their guidance and encouragement in all our efforts. My heartfelt thanks to my head of the department and my professors who worked hard to ensure this event becomes a milestone. My special thanks to all our students who actively participated. Once again, thank you all.
Thank you all. The feedback cum attendance form is there in the chat box. Please fill it before you leave. It will be active only for 15 minutes. Okay. Thank you once again. Have a great day.